Hello everyone and welcome to Looking for Pythagoras 3.2. I have your ACES questions for 3.2, 3.3, and 3.4 listed here. If you want to pause the video, you can write those down to look at later. Now, discovering the Pythagorean theorem. We kind of touched on this in 3.1, but let's expand on it here in 3.2. The theorem is a squared plus b squared equals c squared. Now, this is only if we're given a right triangle, okay? If it's not a right triangle, it will not work with the Pythagorean theorem. So what this means is leg squared, meaning this leg, plus leg squared, meaning this leg, equals hypotenuse squared, or this leg. Remember, the hypotenuse is the longest side, and it is also the side opposite the right angle. Now it says a square drawn off a leg plus a square drawn off a leg equals a square drawn off the hypotenuse, meaning this square drawn off this leg plus this square drawn off this leg is the same size as this square drawn off the hypotenuse. Okay. Now we can use this in two ways. If a squared plus b squared equals c squared works for given side lengths, then the triangle is a right triangle. Also, if given any two sides, we can use the a squared plus b squared equals c squared to find the third side. Let me give you an example. Okay, we have both of the legs, the distance of both of the legs. The distance of this leg is 4, the distance of this leg is 3. So if I put in 3 squared plus 4 squared equals c squared. Well, 3 squared is 9, okay, plus 4 squared is 16, okay, equals c squared, okay? Well, 9 plus 16 is 25, and that still equals c squared, okay? Now, if we want the length of c, or the length of our hypotenuse here, we need to take the square root of c squared to get c, and whatever we do to one side, yeah, we have to do to the other. So the square root of 25 is 5, okay? And the square root of c squared is c. So c equals 5. That means our hypotenuse is a length of 5. Okay? Well, sometimes we're given the length of the hypotenuse and the length of one leg, and we need to find out the other one. So we just substitute in what we have into the equation. So I have one leg, I'll put it in for a squared. So I have 5 squared plus b squared, because we don't know the other leg, equals c squared, or our hypotenuse, which is 10 squared. Well, if we do the math here, 5 squared is 25, okay, plus b squared, okay, equals 10 squared, which is 100. Well, if we solve the equation for b, we subtract 25 off of both sides. We're left with b squared equals 75, okay? B squared equals 75. So we need to take the square root of b squared to get b, and the square root of 75. So b equals the square root of 75. Now, if it asks for decimals, you would have to estimate that. It's going to be around, or use your calculator, it would be around 8.6 or whatever. But the length of side B is the square root of 75. So this whole Pythagorean theorem is saying that the square of the side length squared of both of the legs will fit into the square of the side length of the hypotenuse. Well, in order to do that, let's show that we have a length of 3 here, because you can count them 1, 2, 3, and a length of 4 here, 1, 2, 3, 4, and we know that's going to be 5 because we just did that right back here. Okay, so we know that 3, 4, 5 is a right triangle and fits the Pythagorean theorem. So let's count up the boxes. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, and over here we have and so we have 9 there, and we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, so we have 16 there, and then if you count these, we have 9 plus 16 equals 25. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If 2 rows is 10, and 4 rows is 20, plus 1, 2, 3, 4, 5. So we have 25. So that's the proof of it. there. Now, a little bit more about Pythagoras and the guy that came up with this theorem. This is one of the most famous theorems in all of mathematics. It's been proven more than 300 different times, and so it's withstood the test of time. Okay, but he was kind of a different sort. This is back in BC, 500s BC, and his followers were called Pythagoreans. These guys were a powerful group. Like they kind of pushed people around. They could do whatever they wanted, and he was their leader. And so, as it says here, it says, I had help. Okay, um, and it also tells us here their influence became so strong that some people feared they threatened the local political structure, and they were forced to disband. However, many Pythagoreans continued to meet in secret and to teach the ideas of Pythagoras. The Pythagoreans held Pythagoras, in high regard, so that they gave him credit for all of their discoveries. So he may not himself have come up with the Pythagorean theorem. It may have been somebody helping him. So we'll get into him a little more later, but I want to show you another way to prove the Pythagorean theorem, and this is Pythagoras in 60 seconds.
Jacob Porter, please come to the office. Jacob Porter.
So hopefully that helps you a little bit. If you need to, go back and watch that video again. Otherwise, be using our theorem, our a squared plus b squared equals c squared. Whoa, we have extra stuff going on. All right, a squared plus b squared equals c squared. So that's about it. Your ACES questions for this are 2 through 6, and look forward to seeing you next time. Hope this was helpful.